Hello and welcome back to our NeuroMaker web series. So my name's Andrew, and right now you're going to see a lot of cool stuff in front of me right now. Now you may have heard that the NeuroMaker hand that you are using is based off of a real world prosthetic. Now that is very true, and there's an incredibly interesting story of how the kind of work that you do in your classroom is connected to actual things that engineers do in the lab. So in our case, just like many of you will experience, our engineers went through a whole iterative creation process where we had to think about the needs of certain amputees and other handicap groups and find ways that engineering could help them. So in our case, it was really interesting. So our company is a brain-machine interface technology company. And what does that mean? Well, if you look at this headband, some of you actually might have one of these in the classroom. This is called the Focus One. And there are special sensors on this headband that can detect your brain activity. And by putting this headband on my head, those sensors are able to pick up very, very small amounts of electrical signals that are coming out of my brain. So when we were demoing this technology at a really big exhibition in Las Vegas called CES, the Consumer Electronics Show, we were encountered by a amputee. And it happened to be a little girl, and she was using this headband, and she asked one of our engineers, hey, could this headband power a prosthetic so I could use it without having to move my other arm or manipulate something else? And that made our engineers think, maybe there is something here. So, like many of you will be experiencing through your NeuroMaker hand, we had to think about the things that were possible with our technology. So what's the first thing you do as an engineer? Well, first, you think of the person that you want to help, right? So we knew that this amputee would need to have some sort of hand that would be able to do similar grips and motions that your normal hand would be able to do. So we needed to be able to test this concept out on something we could create easily and cheaply. So where did that take us? Well, you'll see all these hands on my desk. Here is one of our very original prototypes. And if you notice something similar, yes, this is very similar to the prototype hand that you have in your classroom right now. This was one of our very first prototypes when we created our brain robotics prosthetic hand. And this hand here was actually programmed so that you would control it with your headband sensor. And actually, if you are interested, you can actually do the same thing with your NeuroMaker hand as well. But what our engineers found through lots of testing and trying out different kinds of motors and different kinds of manipulation, we found that a prosthetic hand is not powered best by brain signals. Brain signals are very messy. There's lots of different things happening. And one thing that you will experience while you use our headband is that being able to control a machine means being able to control your brain at the same time. So that's very difficult. So our engineers thought, okay, well, if you can't control a hand with your brain signals, what other signals exist in our body? Well, just like your brain produces small electrical signals that these sensors can pick up, your arm does the exact same thing. So as you will learn in our biomedical unit, each time you move your fingers, this is coming from different neurons that are firing inside of your arm, and they tell your fingers to move in a certain way. And these neurons give off small electrical signals that you can pick up with very similar kinds of sensors. So, what did our engineers do? Well, we started to develop things like this. So this is one of our early versions of a device that you would put on top of an amputee's residual limb. And all that means is whatever is left of that amputee's arm. Of course, they're probably missing part of their hand, so there needs to be something that we can use to detect those signals. So an amputee would put their arm in something like this, and inside here, there would be very similar sensors that you would find on your headband. So these electrical signals were measured, and we were able to do different tests, just like with the kit that you have in front of you right now. So this led into all kinds of development. So our engineers found that you can control different kinds of hand gestures through special signals that you can detect in your arm. So just like you in the classroom thinking like real engineers, we had to solve this step by step and try out different methods to see what worked. So where did that lead us? Well, you can see here that we have lots of different hands in front of me at the moment. So this led us into this prototype. So this was the next version of our prototype of the Brain Robotics hand. And as you can see here, we were able to take the basic motions that you're able to complete with your NeuroMaker kit and slightly change the way the motors were positioned. In this case, we actually used linear motors so that your fingers could be controlled a little bit more smoothly than with some of the things that your kit might be working with at the moment. And we were able to design something that we could then test again. And what we found with this iteration of the hand is that you could control different hand gestures with those muscle signals and be able to pick up rudimentary objects. So now that we cleared that hurdle, we were able to continue our development even more, leading into this version of the hand. And as you can see here, you are going to notice some very similar things on your NeuroMaker kit. So for example, just like your NeuroMaker kit, we need to have a control board that's able to sort out the information that's coming into the kit and be able to translate that into different kinds of movement. So you can see that chip right here, and you're going to notice that is very, very similar to the Uno board that is powering your NeuroMaker hand at this very moment. You will also notice that we use that same Uno board in our original prototypes for the hand as well. And just like you can find in your kit too, we had to use different kinds of motors. So these motors, we had to test out the movements of all those different fingers using a slightly different mechanical method. However, the same principles of this movement you can find in your NeuroMaker kit. So we had to think of the ways that you'd be able to bend different digits, how you'd be able to get different kinds of torque from your motors in order to make these special hand gestures. So all of that can be seen in some of our original prototypes, and you can end up seeing on your NeuroMaker kit as well. And all the way down to different sensors. So in this case, we inside of your box, you can find an IR sensor. You can also use different sensors connected to your computer, like a camera or a microphone, and those will be very similar to the kinds of inputs that are coming from those muscle signal detecting sensors that we used in our final product and our prototypes. So you can see all of those fundamentals inside of this. And finally, that led us into this sleek, beautiful design. So you can see this whole process took place over the course of many years. We had to do multiple different tests, fit dozens and dozens of different kinds of amputees, try out lots of different programs, and these are all things that you're going to be able to experience with your set so that you can figure out all those different iterative design things that we had to tackle in order to get to this final prosthetic. So there's going to be a lot of things that you're going to learn throughout your curriculum to unpack all of the things that happen inside of this process. But just from you can see in front of me right now, all of the things that you are working on, do not expect to get the right answer the first time. Do not think that you have the answer to anything and build backwards from that. You are going to need to try to test out different things little piece by little piece, learn each piece of code one piece at a time, so that eventually, after many years of hard work and after many failures, you will get one success. It doesn't matter how many times you fail, just so long as you can succeed once. So we hope that you can relive this process with us, and you can see all of that in front of you right here. So join us for some more introductory videos on how you can learn more about your NeuroMaker set, and I hope to see you more and learn a little bit more with you. So thank you very much.